Good afternoon, good morning, everyone. Welcome to this webinar. I see you're trickling in, so while we wait, maybe a minute or two, allow us to brief you a little bit on the housekeeping. So please, if somebody could give us a thumbs up in the chat that you are able to send a message, or in the Q&A session, that would be fantastic. And basically, if anything pops up during the meeting, any questions you might have, please type it in the chat or in the Q&A session, and then we will tackle them at the end of the meeting. As you can see here on the agenda, it's going to be about 5 minutes about Enact, so what we actually do as a company. Then we will move into the demo part of things. So we will be looking at the PVCAD product, which is a utility scale design tool. And then we will conclude in the Q&A session, where we will tackle all your questions that you might have. Can I please get a thumbs up or a small message from somebody in the audience to see that we are okay in terms of setup? Okay, give us about 30 seconds more. I see people, the number of people is increasing. Okay, so we are ready to go. So again, welcome everyone. As I mentioned before, welcome to this webinar of detailed engineering using PVCAD. And on the agenda today, we will start with a couple of minutes about Enact as a company. Then we will switch into the actual demo side of things. So we will be looking at a utility scale design built with PVCAD. And then we will conclude in a Q&A session. So please feel free to ask any questions during the demo as well, and we will be answering them at the end. So about Enact Solar. So what our vision is, we want to unify the full solar project lifecycle. So again, unifying the full solar project lifecycle from proposals through design, engineering, and lastly, asset management on a single AI-based platform. If you look into the product offering, we actually follow the typical project build-up lifecycle as well. So we start with design and proposals, meaning we can do quick designs and quick proposals for your teams, including utility scale and also CNI projects. We can also do this in a web-based environment, which is quite handy, which also contains the ROI, the pricing, the incentives. And finally, we can customize your proposals with your own branding. So let's say once you have done those proposals, you send out about 10, 15, and hopefully you win all of them, of course, but you probably will win about 20% of those. You can continue your design flow in the detail engineering part. So this product is called PVCAD, and it's an AutoCAD extension where you can dive into the details of the electrical design, the energy analysis, the final BOM of the project. So, and the output of this will be a construction-ready design, which is of great detail. And once you have built your project, of course, we also have a solution for asset management, where you are able to monitor your fleet, integrate multiple inverter brands or other hardware as well. And you can also monitor your ROI and tracking the asset performance as well. So on that note, Deep, I'll pass the baton on to you.
Thank you, Peter. The purpose of a single platform, of course, is to have a life cycle benefit for companies that develop large projects. You're not just putting panels on the ground, you're also delivering power to your clients who need to benefit from the value of the power, which could be financial savings or revenue. So Enact tracks financial performance of projects live with all the detail, whether it's behind the meter of electric rates, as well as, of course, generation and storage. And we're open to any OEM. We're integrated to, of course, all the major inverter brands. And as we track performance, Enact has AI that can optimize the system operations for asset management. So predicting failures of devices ahead of time, as well as warnings to maintain or replace them. and guiding the asset owners on what's wrong and what could be wrong. And then we are backed, of course, by a network of partners in the US already that can repair and maintain projects. And that brings access to a network. And this is really helping asset owners. So we hope this is a value that you guys can use in your own companies. And we have done this now for lots of clients. Peter, on the next slide, if you look at our history, we have been already in Europe for over 6 years, and of course, US for over 10 years with large developers as well as finance partners. We work closely with battery OEMs, and we have also started working with financing companies in the US market. So, with that, Peter, back to you.
Thank you, Deep. So I guess it's time to dive into the actual demo. So Rohit, if you can please take the screen over from me.
Sure. Thanks, Peter. Thanks, Deep. So I'll quickly get started by sharing my screen. Hi, everyone. Good evening. Right. Okay, I hope everybody is able to see my screen. Now, PVCAD, as some of you would already know, that this is a plugin that comes with AutoCAD. And you basically install the plugin, and then there are these templates that you can start with. So if you see, there are different tabs here at the top. Starts with the project details, site objects. So I'll go through all the mechanical and the layout and the designing side of the platform. So either you can just update all the project information here, or you can also upload all of this information through a file which could be simply used to update all the project information. Now the templates have different tabs, so all the plan sets are in different tabs here, and you can of course take one of the templates that's already in the application. Also move around, like let's say the title block or the other information. You can just move around and create your own customized version. But everything actually starts with starting to model the layout and starting to build the system. So I'm going to take an example of a ground mount design, maybe a few megawatts, probably 10 to 15 megawatts that I would like to show today. So you can start by setting up your units either in inches or meters or feet. You can adjust all of that. Now there are two options for you to start your design. One is either you upload a KMZ file, or you can use Google Maps. As we're already integrated with Maps, you can use that. Punch in the lat long coordinates, or just the address, and get to the location of the land parcel or the property. Or you can simply upload a KMZ file from the system. So this is an upload of a KMZ file. And you see, I've already got some boundaries that I've already set up. You'll be able to see on this one has a road, a few buildings here, a stream, a pond. So all of that has been, kind of laid out, through the file. Now you can decide to either leave the background or lose it, completely your choice. A toggle, just a button switch away, and then you start by defining all your layout properties here. So basically you define what is the outline of the parcel. You define all the obstacles that are in the layout. So you see now, basically, you can adjust, add setback either individually, or let's say a uniform setback that you can, adjust for the land parcel, and then also, add different obstacles, and you can, define them as obstacles there. Right. So then we switch to the mechanical layout, and these are all the layers that you can also define in the system, right? So all the obstacle setbacks are defined as different layers here. When you switch to the mechanical layout, which is the third tab, on the right, you can basically now add different types of trackers, right? So I'll just wait for this to complete, and then in the mechanical, you can use either fixed or single axis trackers. So we're already integrated with that. You can define which modules you're going to use for this entire design. Now we have all the latest modules in the system. But if you want to upload your own, PAN files, you can simply go into the database, and upload any module into the system. Now you see, once you select your modules, you have different layout options on the right, right? So you can adjust your GCR, your row spacing, all of that adjustments that you can do while you're doing these layouts. You can also, yeah, so this is basically where you go in and, import your PAN file if you, want to upload any module here. Now, all the attributes that you're seeing here, the GCR, and when you change that, so let's say for this design, we changed this to, uh, yeah, these are all the panel properties. And then if you decide to change this to 0.3 GCR, you would see the row spacing and all of that gets adjusted on its own. You can also adjust all the peer distances. So you can make those inputs here and also select the structure, which is a 3-2-1 of the base structure in this case that we're using. Now, after you've made these inputs, you can then start laying down the panels, right? So you basically can decide what is the azimuth and the direction of the panels that you're going to use. All your trackers get added into your layout. Now, there are multiple ways of managing this layout, right? And when you do this, you can very easily switch to the summary tab and look at, what is the total system size, what is the generation, total number of trackers, total number of modules. All of that you can, look at very easily on summary as you're, doing this design. Now, going back to the mechanical layout again, like you've seen, you can remove trackers, you can add, more trackers. Again, different ways of doing this. Either it could be just the default layout, whatever layout that you've already used, or you can also do it basis a reference on the side, right? So if I want to, have a reference to, the sides of the land parcel, I can define that reference point and also place the panels here. So let's say this particular side, if I have taken a reference and added, like a reference line here, I would be able to add all the trackers basis that line, right? So yeah, all of these adjustments which you can do. Now, let's say, if you want to decide, you want to do a 10 megawatt design, you can also define that in the max DC capacity. So let's say I'm defining this to a 10 megawatt, and that is where, you start making your layout, right? You pick a center point, and all your trackers would be placed around that center point and maximizing it to 10 megawatt. So you would basically be able to pick that point and add all the trackers, and that way you get your layout for your desired megawatt capacity, right? Uh, so there is, yeah. So this is one way of doing these designs, right? The other way also is where you could do a grid style layout. And that's where you create your, different boxes. Again, you can define your number of structures, east to west, north to south. You can, put in all the attributes here on the right side. You can also place an equipment pad while you're doing these blocks, or grid style design, and also look at, how this is going to ultimately come out, clicking on that info button, right? So what I'm using right now is a max capacity fill. So it'll take the full blocks, also the partial blocks, wherever it could fit. You can switch from that to, let's say, a regular fill, right? And that would only take a complete full box or a full block, and exclude everything which is a partial block in the design. So let's look at an example of that. And like I said, you can make changes here to the widths, and you're then basically adding all the panels in the system. Right, so now these are all the blocks that we've added. What I've done first is a max fill. This is the equipment pad, and then you basically add all the trackers, and that get added to your entire layout. While you're doing this, like I've mentioned, you can at any time switch to the summary tab and look at what your design is coming along with, meaning the total system size, your generation, and all the other details. Okay. Now, once you do that, we also have very detailed topography analysis. So if you have a topo file in CAD with contours, you can upload that and use that to do your topography analysis. Or we also have Google elevation services. So that will basically, create a topo analysis and give you, I'll show you how this, you can look at in Google Earth as well, like the Google Earth KML file, and see the actual design and which are the hilly areas, so you can complete your peer schedules as well. So at this point, you see there is Google Elevation Services. You will see there is, you can import that topo, and also look at, this. So when this completes, you would see there are very, fine points in the system. These are little dots, which you can now see when we change the view. And these are basically 3D point, clouds from the point cloud, and you see which are the hilly sides of, of the layout. While there'll be a very good and a better representation as well of this when you complete your, peer analysis, and you would get to see in different shades, like a shade of red everywhere where there is, like a elevated or a hilly area in the land parcel, right? And you can complete that with all the adjustments of pier heights. So basically what it does, it takes and calculates every single pier with all the inputs that you have punched in here, right? And gives you like a, uh, yeah, so this is basically where you get to see, all the areas which are in red are basically your hilly areas. You can download the peer schedule, a very detailed document in Excel with all the peers, and you can download this from the platform as well. Uh, what you can also do in the platform, when you've done your layout, is also take your bill of material, and remember, we've not completed the stringing, the SLD, so that's all coming. We'll show you that in a bit. But at this point, if you want to look at your bill of material of the trackers, you can very easily export that as well from the system. And like I've mentioned, while we were looking at the topography analysis, you can also import Google Earth KML and look at this in a 3D view of how this ultimately how this entire layout is going to look with all the hilly area. These were the areas that were showing red in our design. And you see that's how it comes out in the Google Earth KML as well. So yeah, that's basically what you can achieve on the layout side when you're doing large utility scale designs. I've just used a 10 megawatt or a few megawatts design, but this can go up to hundreds of megawatts of designs, and very easily can be used, to complete your layouts. Now, the last thing that I want to mention here is you also can take a PVSys package. What this means is it will give you a bunch of files, which you simply can import into PVSys application. and get your generation file from PVSys. So you don't have to do these, detailed layouts in PVSys. It's already completed, and it's a PVSys ready package that can, very easily be downloaded, and then eventually you can upload that in the platform. All right. So yeah, that's basically what I wanted to show on the layout. Back to you, Peter, or maybe Deep, on stringing and SLD.
Thank you so much, Rohit. I'm going to focus on the SLD, and so I'm showing on my screen a layout just like Rohit left it. It's a simple layout, already done, ground mount single axis tracker, um, and we are focusing only now on the stringing portion. So to get into the stringing, you have to first identify the sections. You can insert your comments and basically select groups of arrays that you can select for different sections here. I think it's about 4 megawatts per section. And as you do that, obviously, you have the option of auto assigning the structures or leaving that as is. It's up to you for single axis trackers. And then comes, of course, as you name this, the different inverters, right? So the rules for inverter selection and DCAC ratios are already in your settings. So once you finish the sections, the platform helps you in assigning the inverters. So in this case, there's four sections, about 4 to 5 megawatts each. And each section, you can on one click auto insert the inverters. And then it will show you, for example, for each section, uh, if you click on that, um, what's the number of inverters. You can also change that. And as you do that, it's creating in the background the sizing logic. And then for each section, you can also then complete basically the SLD on one click. So I'll skip ahead to that. Once you've finished assigning the inverters, then the last thing is on one click of a button, which is on the top, you can get into the SLD. So here, for as you can see, for each each section, the string conductors are added visually. You can see where they are. Um, you can zoom in and, of course, understand if you want to visually see each string back to the layout of the modules, for example, you can to verify. When you're happy with the connection points, that's when you go and you complete your SLD creation. So on the top, you can save it, and then on the top right, click on single line diagram. It runs SLD for the whole array here. It's about 20 megawatts. And once you run the SLD, it will first create the diagram for you on your model space. On the left, as you can see, you can just drag it and zoom it. And then you can take that into the drawing space as well. So you can see how each array, for example, here, all the properties for the modules, the inverters, the capacity calculations, of course, for output current, and then down to each, basically each string and all the strings in an array and all the grouping, it goes straight into the drawing plan set. You can adjust this. This is not final. You can um, create some nice blocks if you want, or have some rules around how you want to show these drawings. The best part I like is once you're happy with your SLD, there's also one click then to export this, and that creates your complete detailed electrical BOM. So here you can see all the different tracker sections. You can, of course, see the wiring lengths for each tracker. You can also see also the groupings with the inverter, and for each section, therefore, this is the foundation of cost, because cost of wiring is a major topic. So I know there's a lot we can show, but we want to make sure you have a good glimpse of Enact's PV CAD, all the way from layout to full SLD and bomb creation in minutes. We've tried to stick to the time, Peter. And so back to you.
Thank you, Rohit. Thank you, Deep, for the detailed demo. And as we mentioned, is basically just the tip of the iceberg. So just to wrap it all up, so we've covered layout creation. We talked a little bit about terrain, and we covered terrain, the stringing SLDs, and the final BOM as well. So on that note, we would like to open up the floor to the audience to ask your questions that might be bugging you, maybe something that we haven't covered. That would be fantastic. And we would be happy to answer those. And while those questions are actually trickling in, I would shoot the first one probably. So how about the yield simulation? How do we calculate the yield, and where can we actually export that to?
Rohit, you want to take that?
Yes. So there is an energy export that that you can run on the PVCAD tab, and that will give you simulation of your yield, your generation. So all your generation numbers are on your energy export. So that's an export that you get from PVCAD.
Ah, amazing. Thank you, Rohit. And maybe on that note, so we've covered like a couple of different workflows, and this is all in the engineering realm, right? But we probably have more to offer within the Enact umbrella. So what else could engineers get from us? What type of projects can we serve?
So I mean PVCAD is like you've mentioned, it is for detailed engineering. You can do CNI projects of, let's say, 500 kilowatt to, let's say, 2 kilowatt, 3 kilowatt, as well as the utility scale projects that you've seen doing can go up to hundreds of megawatt size of designs. So the application works well for CNI and utility scale projects. So yeah, it caters to different types of projects, different sizes, depending on what is the need and requirement.
I would like to
Excellent.
add, to that for customers who focus mainly on CNI, we have a PVCAD rooftop version, which shows the actual panel on the visual and has a much more granular panel level properties showing on the drawings, because you have to then on the SLD then label them and so on. But of course, when you get into the megawatt ground, uh, the panels become objects. But you have both on PVCAD. You can decide whether you're doing rooftop or ground mount, and the abstraction helps you.
Uh, Thank you, Deep. So we have an interesting question here from Kanzel, if I'm pronouncing your name right. Apologies if I don't. So in addition to the yield calculation and monitoring, we would like to ask if we can monitor the efficiency and also the performance of each panel during the day at different hours, different temperatures that might affect the yield.
Yes, so as I was mentioning you can on PVCAD, for example, you can get into panel level generation. For the larger ground mount sections, we have the ability to create sections or blocks to do that. You lose the panel level detail when you're creating blocks. So uh, depending on the type of project, you can definitely choose which way you want to go.
So basically, we can zoom in and out depending on whether you prefer, a top-level view, or if you want to zoom into the even panel-level nuances and figure out, what are the details that you will still need to tweak. Are there any other questions from the audience? Let's wait another minute. Maybe we can also talk about the entire workflow, right? So we were basically moving mostly along the realms of engineering, right? But of course, before we get to the engineering, as we mentioned, we also have a solution for the sales side of things. So maybe Rohit, if you can cover that, of how that transitions and feeds the engineering funnel.
Yeah, sure. So basically, we have the pre-sales side of the platform as well. We call it Sketch Mega, and that is where you can do your ground mount layouts, very detailed again, and look at what layout works and optimizing design. So you basically have all the different variables. You can look at 7 8 different layout options, designs, what works well, and you can pick out of all these 7 or 8 different suggestions that the system is giving you, and decide on what your layout is going to be, right? But that's on the pre-sales side. So when you have to take that design into PVCAD with a click of a button, again you can export that from the pre-sales software into the PVCAD detail engineering software, and continue your electrical engineering and mechanical engineering, and then finally get your stringing, SLD, and PVSys packages downloaded from the platform. So yeah, this is what I was referring to, and it'll give you a view of how this layout with different variables is going to play out, and then you can pick the design that works well. So it really helps on the optimization for large scale projects.
I would like to
Excellent.
add that if you're looking for optimized solar layout, for example, uh, selection of lowest cost of energy, you're playing with GCR or DCAC ratio here, you can get to that. It takes a few minutes to run all the scenarios and gives you the optimum, and then export that final run into PVCAD for AutoCAD. So you eliminate a lot of time wasted later on if you get to the optimal design and then go into PVCAD, of course, for the rest of the layout details, generation, and yield, as well as the SLDs.
Indeed, indeed, and I guess it's all about the efficiencies gained, right? So you can be much more efficient as an engineer, and also in the pre-sale side as well. But we actually got some interesting questions here, so you guys have triggered the audience. So how about the licensing policy and what are the trail options, etc. Trial, oh, excuse me, trial options. Maybe that's for you, Deep.
Yeah, so we have a license assigned to a machine. As you know, PVCAD runs on Windows, and so it's a Windows-based device that we can operate on. And so we give a license to a machine, and therefore, at one time, you can have only one person use it. But some companies have shared licenses, meaning you can have one machine used by two people. And if you can figure out how to kind of use that. Um, for PV Sketch Mega, we of course have user-based pricing. It's on the web. We have very, I would say, open pricing, meaning you can pay annual or you can pay monthly. Annual is a discount, but many clients choose to still pay monthly and then convert to annual later to avail the discount.
And also, there are some interesting packages available, of course, in terms of multi-user packages, and also when you're bundling PV Sketch with PV CAD as well. So I hope that answers your question, Bat. But feel free to drop us an email. The contact details are on the screen, and we will be happy to answer your questions. We have a very tricky question now here. So how do we stack up against PV case? So what are our strengths against PVKs?
Great question. I'll try first, and Rohit, you can take on. PVCase is a great product. As you know, it's been on the market also as long as ours has been, and mainly in Europe. We started with the US, and we are growing in Europe. I would say in certain areas like battery storage, we have started doing solar with storage on both the web application as well as the CAD application years ago. So we didn't show that today, but you could do a battery plus solar DC coupled SLD, and a lot of other features around electrical design, especially when you're doing CNI battery storage with solar. That's, I would say, an example of a differentiator. But of course, the biggest feature I would say is the ability to keep the complete life cycle on one platform. So not just stop at the design, but actually have an asset management view of all your sites in one place. and track the generation, compare the measure to the actual, and have the whole experience of performance tracking. I would say that's our biggest differentiator. But there's many more feature level, I would say, differences. And Rohit, maybe over to you if you want to add a couple more.
Sure. Yeah, just to add a couple of them, like Deep mentioned, the storage side of designs can very easily be baked into the overall project design. Also, the terrain tracking feature, which is also part of our layouts and mechanical engineering, that is one of the features. Now, also talking about the overall workflow, right? So now, if you've looked at, when we spoke about Sketch Mega, which is on the pre-sale side, and you do your layouts, you do your optimized designs, and pick, from different options that you get, and then you transfer that into PVCAD. So everything you see eventually works as a complete flow, a complete package, right? So you start with pre-sales, then you have detailed engineering with PVCAD, and then you get into the asset management and manage all your assets and look at how they're performing. So what we build is an end-to-end workflow for any company, and basically starts at the pre-sale stage, and ultimately after you install, you continue to manage those assets with all the engineering applications that we have.
Thank you, guys. I think those were quite exhaustive and comprehensive answers. So, if there is no more answers or no more questions from the audience, I think we are actually running out of time. So, thank you very much for your attention. Thank you, Rohit and Deep, for showing the platform. But one thing I actually want to finally emphasize is that this is just the tip of the iceberg. So, as we mentioned, we serve an end-to-end workflow where we are able to address more or less any solar company in the development EPC space. So feel free to reach out to us. The contact details are on the screen, and we are happy to schedule either a demo or a free trial for you. So don't take our word for it. Come and try. And thank you very much for your attention, and see you at the next one.
Thank you, Peter.
Thanks, Peter. Thanks,
Hi,
everyone.
Rohit.